So in the previous video we have completed till number 4. Now we will start with number 5. Students, can you see the difference here? So here we can find that carbon has made a covalent bond with chlorine, that is a halogen. Similarly in 6 also we have bromine, that is a halogen. So now we need to know about functional group to solve from sum number 5. So my dear students, for solving rest of the IUPAC nomenclature, you need to know more about functional group. What is a functional group? A functional group is the group of atoms which imparts specific characteristics to hydrocarbons when they are attached with the hydrocarbons. What is a hydrocarbon? We have already learned hydrocarbon means the compounds which consist of only hydrogen and carbon atoms. Now in place of this hydrocarbons, if we find the attachments of these functional groups, that is halogen, alcohol, carboxylic acid, aldehyde and ketone, then we will call them as functional group, because if these functional groups are attached with the hydrocarbon, the characteristics of the hydrocarbons will be changing. So here we have halogen. Halogens are the elements which are found in the 17th group of the modern periodic table. For example, you will find the attachment like this, that is of chlorine, of bromine, of iodine. If we find all these things with hydrocarbons, that means we have the functional groups of halogens attached with that hydrocarbons. Next we can find the attachment of alcohol. If attachment of alcohol is there, you will find this symbol attached with the hydrocarbons. Next we have carboxylic acid. How you will recognize carboxylic acid? You will find here that with carbon atom you will find OH, and here you will find the symbol of oxygen like this. That means we have carboxylic acid there. Aldehyde and carboxylic acid, how you are going to differentiate is, in carboxylic acid you will find the attachment of OH here, and here instead of OH only hydrogen will be present. So this is aldehyde. Now what is ketone? Ketone means here carbon is there, and here are the two hands of carbon. We know there are total 4 hands of carbon, and here we will find here ketone. That means here hydrogen will not be attached. Here instead of hydrogen you can find carbon itself. So if this oxygen comes in the middle carbon instead of the end carbon, then it will be recognized as ketone group. So now let's find out how we are going to name the hydrocarbons or the hydrocarbons which is having functional groups in it. So let's start. So first one, as you can see, we have 1C, that is 1 carbon. So you will get the prefix as meth for 1 carbon. Now as you can see here, all the bonds are single bond, so you will have methane, ANE. But here we have the chlorine, that is the halogen here as the functional group. So how it will be written? If we write methane, it's wrong because we have chlorine atom. So now let us go through the halogen functional group. So as you can see, in a halogen functional group, if you find chlorine, bromine, iodine like this attached with the hydrocarbons, then halo will come as the prefix. Prefix means before the name of the element that you have written. So let's write it. So here we have found out that it will be methane, but here we have chlorine attached with this. So as a prefix we will get here chloro, as it is the halogen and halogen comes as a halo, so it will be chloro, then we will write methane after it. So this is our final answer. So this is chloromethane. Now let us move on to next one. So similarly, as you can see here, we have one chlorine, so we will get the prefix as meth, and as single bond is there in between all the elements, so it will be ANE, methane. But here we have the halogen Br, that is bromine, so you will write bromo. So you will write bromo as the prefix here, as it is the halogen. So your answer will be bromomethane. Now, as you can see in number 7, here we have the attachment of OH that we have learned to be alcohol. So as it is alcohol, let us go through the functional group of alcohol. So as we have found this attachment here, that means it is under the functional group of alcohol. As you can see here, E will be cancelled and you will write OL as the suffix if it is alcohol. So let's see how you are going to write. So here first you can see here we have one C, that is one carbon. So you will get here as meth, and as single bond are there in between all the elements, so it will be ANE, methane. But here as we have the functional group OH, that is of alcohol, so according to the rule this E will be cancelled and we need to write OL after it as the suffix. So this compound will be named as methanol. So this is our answer here. Let us solve the next one. Here we have 2C, meth. Next we have eth. So you will get here eth as the prefix. Now as you can see, in between all the elements we have single bond. So here you will write ANE, ethane. But here we have functional group OH, that is of alcohol. So according to the rule, this E will be cancelled and you need to write OL. So this will be ethanol. So this is our answer here. Now let us move on to number 9. So here as you can see, we have two C's, that means meth, eth. So you will write here the prefix as eth. Now as you can see, between this carbon we have double bond instead of single bond. So if there is double bond, you need to use in, E-N-E, in, not N. So here we have used E-N-E, in, and here you can find the functional group as OH, that is of alcohol. So according to the rule, you need to remove this E and you need to write OL here. So your answer will be ethanol here. So this is our answer here. Now let us start with number 10. So here as you can see, we have one C, that means it is meth. It is meth. But here we have one C, that means in between C we have single bond. So we will use here ANE, methane. But here you can find the functional group, that is carboxylic group. We have already learned here. This is the structure of carboxylic acid. So same structure is given here. So here what is the rule? You need to cancel the E and you need to add oic acid as the suffix. So let us see how you are going to write it. So here according to the rule, you need to cancel this E and you need to write here oic, O-I-C, oic acid, ACID. So this is our answer, that is methanoic acid. So this is our answer here. Now let us move on to the next one. So here also we have the functional group of carboxylic acid. Here we have two carbons, so meth, eth. So you are going to use here eth. And in between carbon we have single bond in all the cases. So here ethane you will write first. And according to the rule of carboxylic acid, you need to cancel this E and you need to write oic acid. So your answer here will be ethanoic acid. So as you can see, we have written ethanoic acid as our answer. Students, as you can see here, we have a note. You need to remember this. With carbon, you need to remember hydrogen always forms a single covalent bond. As the valency of oxygen is 2, so it will always form double covalent bond with carbon. As in case of nitrogen, the valency of nitrogen is 3, triple covalent bond with carbon. Similarly, with hydroxide, it will form mono, that is the single covalent bond. So if the bond is single, it will be named as mono. If it is double covalent, it is di. If it is 3, that is the number of covalent bond is 3, it will be tri. And here also mono, as one covalent bond is there. You must remember the maximum number of covalent bond between any element will be 3, not more than 3. Now let us move on to the next one. Now let us start with number 12. So here the difference between 10, 11 and 12 is, here we have H instead of OH, and here we have O attached with the end carbon. So this means this thing is of aldehyde. So let us go through the functional group aldehyde. Always remember, aldehyde will be attached with the terminating carbon, that is the ending carbon. So here we have this carbon at the end, and here we have H, and here we have oxygen. So here if it is aldehyde, then we need to cancel the E and you need to add Al as the suffix. So let us see in this one. So here as you can see, we have 2 carbons, meth, eth. So you will get here as eth. Now in between carbon we have single covalent bond, so ANEN. But as it is aldehyde, you need to cancel this E and you need to add Al. So it will be ethanol. So your answer will be ethanol here. So always remember that the aldehyde will be attached with the ending carbon. It may be in the beginning, it may be at the end, but it will be not attached with the middle carbon. So now let us move on to next one. So in number 13 you can see we have 3 carbons. 3 means what? Meth, eth, prop. So you will use here PROP, prop. Now as you can see, in between carbon we have single covalent bond, so it will be ANEN. As you can see, there is no functional group, so this will be named as propane. Now let us move on to next one. Now as you can see in number 14 also we have 3C, so you will use PROP, prop, as the prefix. And here as you can see, between carbon we have single covalent bond, so it will be ANEN. But here at the terminating carbon we have the aldehyde functional group. So the rule of aldehyde is you need to remove this ending E, this E at the end, and you need to use Al instead of that. So it will be propanol. So this is our final answer here. Now let us move on to the next one. We have 3 carbons, so it will be prop, and in between carbons we have single covalent bond, so it will be propane. But here as you can see, with the middle carbon we have the attachment of O, that is oxygen, and you know this functional group as ketone. So let us go through the functional group of ketone. So if the functional group is ketone as like this, then you need to cancel this E at the end and add ONE1 as the suffix. That is, at the end you need to write ONE1. So let's see. So according to the rule of ketone functional group, you need to cancel this A. Instead of that, you need to add ONE1. So here our answer will be propanone. So propane 1. So here answer will be propane 1, as here the functional group is ketone. Let us move on to the next one. as you can see, in number 16 we have 1, 2, 3, 4, 5, 6 carbon. So for 6 carbon you will get the prefix as HEX, hex. Now in between the carbon we have single covalent bond at each and every place. So it will be ANEN, hex N, as we don't have any functional group here. Here we have only the hydrocarbons, that is hydrogen and carbon. So it will be named as hexane. Now let us move on to the next one. Now let us start with number 17. Here also you can see 1, 2, 3, 4, 5, 6 carbon are there. Here the prefix will be hex, and in between the carbons you have a single covalent bond, so ANEN, hexane. But here we have the attachment of functional group chlorine, and we know for halogen you need to use it as the prefix. So here we have chlorine, so it will be chloro, CHLORO, chlorohexane. So our answer here will be chlorohexane. If the carbon will be attached with the ending or the terminating carbon, this one is a terminating end and this is the terminating end. If it will be attached with the terminating carbon, then you need not to give any number. You will just write chlorohexane as the answer. Now if you find this functional group in the middle somewhere instead of the terminating carbon, here terminating carbon is this one and this one, but it is attached with this carbon. So how you are going to write the name? So let's see. So now let's start with number 18. So here as you can see 1, 2, 3, 4, 5, 6, 7 carbons are there. So we will use the prefix as HEPT, hept. Now in between the carbons we have single covalent bond, so we will use the suffix ANEN, heptane. But here we have the functional group, that is halogen, chlorine here. So here we have chlorine. As you can see in the previous one, chlorine was attached with the terminating carbon, that is the carbon at the end. It may be this side, it may be this side, but it was attached with the terminating carbon. But here the terminating carbons are this one and this one, but here it is attached with this carbon which is not the terminating carbon. So you need to give the number here before writing chloro. So here my dear students, if we count the number of carbons from this side, you will get 1, 2, 3, 4, 5, 6. You will get the chlorine in the 6th position of the carbon. But if we count from this side, you will get in the 2nd position. So here always remember you need to consider the shortest distance or the nearest one. So here you need to consider 1, 2, this one. So you will write here 2 first, give a dash or hyphen, write the halogen, that is chloro, 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 and heptane as it is. Always remember in between the number and hyphen will be there. So let us start with number 19 now. So here in number 19, as you can see, we have 1, 2, 3, 4, 5, 6 carbon. So you will use the prefix as hex. In between the carbon we have single covalent bond, so ANEN here. Now you can see the functional group chlorine or halogen here. So as this chlorine is not attached with the terminating carbon or the carbons at the end, you need to find out the position. If we find out the position from this end, you will find 1, 2, 3, 4th position. If we count the position from this end, you will get 1st, 2nd, 3rd. You need to consider the shortest or the nearest position. So here you need to write 3, then the halogen is chloro, so CHLORO, chlorohexane as your answer. Let us move on to next one, that is number 20. So here as you can see we have 1, 2, 3, 4, 5, 6 carbon. So you will write here hex. In between the carbon we have single covalent bond, so ANN. Here also you have the functional group, that is halogen, chlorine. So if we count from this side, you will get 1, 2, 3, third position. From here 1, 2, 3, 4, fourth position. So you need to consider this one, that is first, second, third, as it is the shortest position. So you will write 3, give a hyphen, write chloro, CHLORO, that is the halogen should be written in the prefix. So chlorohexane. So your answer will be 3-chlorohexane. If you have written the position from this side and written 4-chlorohexane, then this would be your wrong answer. So always remember, numbering should be given from the nearest one. So let us move on to number 21. Here as you can see, we have 1, 2, 3, 4, 5, 6 carbon. So you will get here hex. Now in between the carbons we have single covalent bond, so ANEN. But here you can find that 2 chlorine or 2 halogens are there. So you need to give the position of the chlorine. If we find the position from this end, you will get here first, second position one, and another at this third position, that is second and third position. If we count from this end, you will get 1, 2, 3, fourth position and fifth position, that is 4, 5. So this is the nearest ones, 1. So you will write 2, 3. Now as you can see, we have 2 chlorines here, that is di. 2 means di, so you need to write di. Then you will write chloro, CHLORO, chlorohexane. So here the answer will be 2, 3 dichlorohexane. Now let us move on to number 22. So here 1, 2, 3, 4, 5, 6 carbons are there. So you write hex. In between the carbons we have single covalent bonds, so ANN. But here we have 2 functional group, that is chlorine attached with the single carbon. If I find the position of carbon from this side, you will get 1, 2, 3, 4, fifth position. If I count from this side, you will get the position of carbon as 2. You need to consider the shortest position, so we will take 2 into consideration. We have 2 chlorine, so 2, 2. So in between number always give a comma, then give a hyphen. Now here we have 2 chlorine, so you need to write di first, that is di for 2, and you will write chloro, CHLORO, as it is the halogen. So your answer will be 2, 2 dichlorohexane. Now let us move on to next one, that is 23. Now here as you can see, we have 1, 2, 3, 4, 5, 6 carbon. So you will get here hex. Now in between the carbon you have single covalent bond, so ANE, hexane. Now here we have halogen. So here how many halogen are there? Here 1, here 1, and here 1. So we have 3 halogens. So here we need to count the positions of the carbon where we have halogens. Now if we count from this side, we will get first, second, third. So here in the second position you have chlorine, and in the third position we have the bromine. But if we count from this side, 1, 2, 3, 4. In the fourth position you will get bromine, and in the fifth position you will get chlorines. So always remember, you need to give preference to the alphabetical order. So which one comes first in alphabetical order? You will get bromine, that is B before C. So as bromine, that is B, is before chlorine, that is C, so you need to give preference to bromine. So you need to find out where bromine is in the shortest distance. So here we have 3, 2, 3 is bromine and 4 is chlorine. So you need to consider this one as the correct one, that is from this side. So here as you can see, we will write 3 bromo, and in the second position we have chlorine. So we will write 2, 2 dichloro, as 2 chlorine are there, so dichlorohexane. So you need to give preference to alphabetical order while writing or writing the names of the compounds. So here, as you can see, we will be starting with number 24 now. So as you can see, how many carbons are there? 1, 2, 3, 4, 5, 6. So you will write here hex. Now we have single covalent bond between each carbon, so it will be ANEN, hexane. Now we have the functional group bromine here, and we have chlorine here. So here also you need to give the preference to alphabetical order. You know B comes before chlorine, that is C. So you need to count in such a way that B gets the smallest number than chlorine. So here if we start from this side, you will get 1, 2, second position chlorine, third, fourth, fifth position bromine. So if we start from this side, you will get bromine in the fifth position and chlorine in the second position. Now if we start counting from this end, you will get 1, 2, second position for chlorine, and 4, 5 and 3, 4, 5 for, that is fifth position for chlorine. So you need to choose this position because here bromine is getting 2 and here bromine was getting 5. So you need to give preference to this one. So let's see how you are going to write. So according to this, bromine will get 2 and chlorine will get 5. So here you need to write 2, that is the position of bromine, dash, that is hyphen, then write bromo. Then we have chlorine in the fifth position, the 5 hyphen chloro, CHLORO, chlorohexane. So our answer will be 2 bromo, 5 chlorohexane. Now let us move on to next. Let's start with number 25. So here we have 1, 2, 3, 4, 5 carbons, and we need to use the prefix as pent as we have 5 carbons. Now here we have single covalent bond, here also single, but here we have double covalent bond. As we have double covalent bond, you need to use ENE in, not ANEN. So ENE in. Now as you can see, double covalent bond with the ending carbon, that means with the terminating carbon. So you can write as it is. If it was here also, that then also you could have written pentene. But if you find this covalent bond at the middle somewhere here, then what would you have done, as it is not with the terminating carbon? So first the rule will be to count the number of carbon, that is 3, 4, 5. So you will write here pent. Now with which we have double covalent bond, here we have double covalent bond, so ENE in. But my dear students, here you cannot write ENE in pentene like this, because this covalent bond is not with the terminating carbon. You need to find out the position of the carbon with which the covalent bond or double covalent bond is there. If we count from this side, we will get first, second, third with the third carbon. But if we count from this end, you will get it with 1, 2, second position carbon. You need to give preference to the smallest distance. So here you will write 2 pentene, or it will be proper if we write pent next 2 in, as it is double covalent bond here. So you will write pent first, then we will write the position, that is second, and ENE in between number and symbol, or number and letter, always hyphen will be given. So it is pent2in. Now let us start with 27. So here how many carbons are there? 1, 2, 3, 4, 5. So you will write here pent. Now as you can see, we have double covalent bond here and here. So we have two places where we have double covalent bond. It is final that you will get ENE in, because double covalent bond is there. But you need to mention the position of double covalent bond. If we count from this side, you will get first, second with second, and here third, fourth. So second and fourth you will get here. But if we count from this side, you will get with the first one, second, third one, So you are getting 1, 3 if we count from this side. Always give preference to the shortest distance. So we will consider this one as the answer. So here we will write hyphen 1, 3, then hyphen, and we need to write di. Why di? Because 2 are there. 2 covalent bond, double covalent bond. So di in our answer here. Let us move on to next one. So here, as you can see, we have 1, 2, 3, 4, 5, 6, 7. So 7 carbon, that means HEPT, hept. Now where we have functional group, we have functional group here and here. This is the functional group of alcohol, and according to the functional group of alcohol, you need to remove E and write OL. So here, as you can see, in between carbon we have single covalent bond, so you will get ANEN, heptane. But according to the rule of alcohol, we need to remove this E and you need to add OL. But here we have 2 OH. So you need to write the position of OH. If we count from this side, 1, 2, 3, 4, 5, 6 and 7, you will get 6, 7. But if we count from this side, you will get first, that is 1, 2. So you need to give preference to 1, 2. So you need to write like this, that is heptane. You need to remove E, and as alcohol is written in the suffix, so you will give a dash. You will write the position, that is 1, 2 dash diol. Why diol? Because 2 alcohol are there, so diol. So this is our answer here. So now let us move on to the next one, that is 29. So here, as you can see, we have 1, 2, 3, 4, 5, 6. 6 carbon, that means here you will get hex. Now in between carbon we have single covalent bond, so ANE, hexane. But here we have the functional group, that is carboxylic function, carboxylic acid. So you need to remove this E and you need to write oic acid. So you need to write oic acid. Always remember that carboxylic acid are always with the ending or the terminating carbon. So you will get the answer as hexanoic acid. So let us start with 30. Here we have 1, 2, 3, 4, 5, 6 carbon. So you will get here hex. Now in between carbon we have single covalent bond. So hexane. Now you can see here also we have a functional group. Here also we have a functional group. And these two functional group are of carboxylic acid, as we have learned earlier. So as it is of carboxylic acid, that is written like this here. So this is carboxylic acid, and according to the rule of carboxylic acid, you need to remove this E and you need to write oic acid. But here we have 2 carboxylic acid, so you need to mention the position. If we count from this side, you will get here first position, second, third, fourth, fifth, sixth, that is 1, 6 position. If we count from this side, you will get here 1, 2, 3, 4, 5, 6, that is 1, 6. So both the sides you are getting 1, 6, that is carboxylic acid is with the terminating carbons. So you need to write here hyphen 1, 6, that is the position of carboxylic acid. Give a hyphen, as 2 carboxylic acid are there, so di. Then you need to write oic acid. Here your answer will be hexane 1, 6 dioic acid. This is our final answer here. So now let us start with next one, that is number 31. So here you have 1, 2, 3, 4, 5, 6 carbon. So you need to write hex here. And in between carbon we have single covalent bond, so hexane. Now you can see here and here we have the functional group, and this functional group is of aldehyde. So as you can see here we have aldehyde, that is carbon attached to hydrogen here, and here we have oxygen. So it is with the terminating carbon always. So here both the ends are the terminating carbons. Now here we have aldehyde. So let us find out the position of aldehyde. Here from this side if we count, you will get first position here, second, third, fourth, fifth, sixth, that is 1, 6th position. From this side if we count, then first position here, second, third, fourth, fifth, sixth position, that is 1, 6 in both the sides. So here if we count from this side or this side, it doesn't matter, so it is 1, 6. So the formula of aldehyde is, you need to remove this E and you need to add Al, but here we need to mention the position as we have two aldehyde, so you need to give a hyphen here. 1, 6 is the position as we have two aldehyde, so you will write di here, and the functional group aldehyde will be represented by Al according to the rule. So here answer will be hexane 1, 6 dial. So this is our final answer here. So let us move on to number 32 so now. Here as you can see, we have 1, 2, 3, 4, 5, 6, 7 carbons. So here you will get here as hept, as we have 7 carbons. Now in between carbons we have single covalent bond, so you need to write N here, A-N-E. But here we have two functional group of ketone, as it is attached with the middle carbon, that means it is ketone. It is not carboxylic acid or it is not a aldehyde. It is not aldehyde. Why? Because it is attached with the carbon in the middle, not at the end. So here we have two ketone. So let us find out the position. From this side you will get first, second, third, fourth, that is second and fourth position. From this side if we count 1, 2, 3, 4, 5, 6, that is 4 and 6 position. So you need to consider the shortest position, that is 2, 6, and as it is ketone, that means you need to remove this E and write O-N-E at the end. But here we need to mention the position, that is 2, 4. So you will write here 2, 4 dash 2 ketone are there, so di 1. So our answer will be heptane 2, 4 di 1. So our final answer here is heptane 2, 4 di 1. So let us move on to the next one, that is 33. Now as you can see, we have 1, 2, 3, 4, 5, 6 carbon. So you will write here hex. Before that you can see here also we have carbon. So if we consider this chain, you will get here 1, 2, 3, 4, 5 carbons. And if we consider this chain, you will get 1, 2, 3, 4 carbon. And if we consider this chain, you will get here 1, 2, 3, 4, 5, 6 carbon. Always remember, while naming the hydrocarbons or while naming using IUPAC nomenclature, you need to consider the longest carbon. So here longest carbon chain is 6, that is this one. Now as you can see, in between the carbon we have single covalent bonds, so you will get here N. But now as you can see here we have CH3, so you need to know this functional group as well. So before writing this name, you must know the general formula of alkane, that is single covalent bond, alkene, that is double covalent bond, and alkyne, that is triple covalent bond. In case of alkane, the general formula is CnH2n plus 2. Here n is the number of carbon. And in case of alkene, it will be CnH2n. And in case of alkyne, it will be CnH2n minus 2. So how you are going to remember? You must remember this one, that is alkene, that is 2n. If you are finding out alkane, you need to add plus 2 here with this 2n. And if you are finding alkyne, you need to subtract 2 with this 2n. So these are the general formula. So in this alkane, if the value of N is 1, that is 1 carbon is there, then you will get here C1 H2N, that is H2 into 1 plus 2. You will get here H, 2 ones are 2 plus 2, that is 4, CH4 as the first element of alkane. If we find out the second element of this alkane, you will get C2. You need to place 2 in place of N. Here also 2. So 2 2s are 4 plus 2, that is 6. That is H6. So you will get C2H6 as the second element of alkane. From this alkane, if we subtract 1 H, you will get here CH3. If we subtract 1 H from here, you will get C2H5. And this is the group of alkyl, which we will learn now. So if we subtract 1 hydrogen from the alkane, we will get alkyl. And it is named like this: CH3, that is the first one, methyl, second one ethyl, third one propyl, so fourth one you will get as butyl, and so on. So let us now write the name of this compound. Now here you can see 1, 2, 3, 4, 5, 6 as we have discussed. So here you will get hex and single covalent bond, so ANE hexane. Now as you can see, we have here methyl as we have discussed. So let us find out the position of methyl in this longest chain. If we consider from this side 1, 2, 3, fourth position, from this side you will get 1, 2, 3, that is third position. So you need to write here the position, that is 3 dash methyl. So you will get here THYL, methyl hexane. Let's start with the next one. If we consider this carbon chain, you will get 1, 2, 3, 4 carbons. If we consider this carbon chain, you will get 1, 2, 3, 4, 5 carbons. Now if we consider this carbon chain, you will get 1, 2, 3, 4, 5, 6. So by considering this carbon chain, you will get the longest carbon chain. So you need to consider this carbon chain. So here we have 1, 2, 3, 4, 5, 6 carbon. So you will get here hex. In between carbon we have single covalent bond, so ANE hexane. But here we have 2 methyls. So 2 methyls means you need to find out the position of methyl. From this side, if you count 1, 2, 3, third position and fourth position, that is 3, 4. If we count from this side 1, 2, 3, 4, that is 3, 4. So both side you are getting 3, 4. So you will write here 3, 4 dash. How many methyl are there? 2. So you need to write di methyl, methyl, methyl hexane. Now let's start with number 35. If we consider this carbon chain, then you will find here 2 carbons, 3, 4, 5, 6, 7, that is 7 carbons. And if we consider this one, you will get 1, 2, 3, 4 carbons. If we consider this one, you will get 1, 2, 3, 4, 5 carbons. So which one is the longest carbon chain? This is the longest carbon chain here, that is 7 carbons. So you need to write HEPT, hept, as here 7 carbons are there. In between carbons we have single covalent bond, so ANE heptane. So heptane is done. Now if we consider this carbon as the main chain, then this one is a branch and this one is a branch. So you need to name the branch. Here we have C3H, that means CH3. So here one CH3, here one CH3. CH3 means what? Methyl. So let us find out the position of methyl. Here we have 2 carbons. So this is the third carbon with which this methyl is attached, and this is the fourth carbon with which this methyl is attached. So you will get here 3, 4 dimethyl heptane as our answer. So with this we come to the end of this topic. You just complete this classwork and submit it in our Telegram group. If you have any doubt, let us know by commenting below or texting in our Telegram group. Bye bye students. Have a nice day. See you in the next class.